Welcome to this video lecture. This is Mark Scythian, FAA licensed aerospace technician, airframe power plant and avionics certified. The date today is July 3rd, 2017. The title of this video is the relationship between mechanical, electrical, and thermal power. Down here I've written the data that links mechanical, electrical, and thermal power into equivalency. If you look at this list here, we have 1 horsepower, which is equal to 746 watts, which is equal to 550 foot-pounds per second mechanical power, which is also equal to 33,000 foot-pounds per minute. 1 watt of power, any type of power, is also equal to 0.737 foot-pounds per second, which is equal to 1 joule per second, which is also equal to 1 Newton meter per second. 1 BTU per second heat output in the form of steam, burning fuel, or any other type of heat. If 1 BTU is released per second in the form of heat, that will equal 1056 watts of power, which is also equal to 778 foot-pounds per second of mechanical power, which is also equal to 1.4 horsepower. AC electrical true power in watts is equal to the root mean square, or effective voltage, AC voltage, times the root mean square RMS effective current multiplied times the power factor. DC electrical power in watts is equal to voltage times current. I will be doing future lectures on both AC and DC circuit analysis, and I'll cover all the details of defining and solving AC and DC circuit analysis variables. Electromotive, that implies converting electrical power into mechanical power by the device known as an electric motor. In that case, the voltage will govern the RPM of the motor and the current will govern the torque. The resistance is proportional to the motor's friction and heat. The brake horsepower of any motor or engine is equal to the RPM times the foot-pounds torque times 6.28 radians. This quantity then divided into 33,000. AC brushless electric motor brake horsepower, that is equal to the RMS voltage times the RMS current times the power factor times an electromotive efficiency of 85%, or 0.85. This quantity then divided into 746. AC brushed electric motor is equal to RMS voltage times RMS current times power factor times an electromotive efficiency of 70%, or 0.7, then divided into 746. DC brushless electric motor brake horsepower is equal simply to the voltage times the current, that is DC voltage times DC current, times 80% electromotive efficiency, or 0.8, for the DC brushless electric motor. That quantity then divided into 746. Then lastly, for the motors, DC brushed electric motor brake horsepower is equal to the DC voltage times the DC current times 50% electromotive efficiency, or 0.5. That quantity then divided into 746 to get brake horsepower. 1 pound of gasoline or petrol has an energy density of 20,000 BTU. 1 US gallon of gasoline or petrol has a fuel density of 6 pounds per 1 US gallon. 1 pound of diesel has a BTU potential energy of 19,300 BTU, and diesel has a fuel density of 7.1 pounds per 1 US gallon. 1 US gallon of kerosene jet fuel has an energy density of 18,730 BTU per pound and a fuel density of 6.75 pounds per 1 US gallon. 1 pound of liquid propane has a BTU potential energy of 21,934 BTU and a fuel density of 4.24 pounds per 1 US liquid gallon of liquid propane, or LP. gasoline piston engine brake thermal efficiency at its maximum at no load conditions is 33%. Diesel piston engine brake thermal efficiency maximum under no load is 38 to 50%. That also includes quite a lot of computer controlled air to fuel mixture ratio variations, heat of air compression. Gas turbine engine brake thermal efficiency can vary between 38% and 60%, depending on static versus, actually this could be turbo shaft too, but during load and no load operations. AC brushless electric motor electromotive efficiency. We went over this earlier, but I decided to list the electromotive efficiency separately, as you can see there. Equivalent heat required to raise 1 pound of water by 1 degree Fahrenheit is also known as 1 BTU. The equivalent heat to raise is required to raise 1 pound of air by 1 degree Fahrenheit is equal to 0.24 BTU. And at 59 degrees Fahrenheit and 14.7 pounds per square inch atmospheric pressure, 1 US gallon of water will weigh 8.3 pounds. And lastly, at 59 degrees Fahrenheit and 14.7 pounds per square inch atmospheric pressure, 1 pound of air will be approximately 13.5 cubic feet. So these are the general relationships between mechanical, electrical, and thermal power. And now you might get the idea that if you're dealing with a burning fuel or a combustible substance, finding the BTU per pound energy density, as well as the burn rates, which is the flame fronts, can also then be translated into equivalent mechanical power and equivalent electrical power, either heat created by electricity or electricity created by heat. That would be thermocouple. There are always going to be equivalents between all power values, and power, watts, implies kinetic energy, and then BTU or calories per given mass, calories per gram or BTU per pound, depending on which system you're using, is implying a potential energy, maximum potential energy available in the given energy that may be converted into kinetic energy in the form of power. Another important value to pay attention to is the efficiency, the general efficiencies, and of course thermal efficiency and electromotive efficiency, but anything that goes from potential to kinetic energy in an imperfect world where there's resistances and there are drag components and there are power lost to keep power plants running, there will never be 100% efficiency, not with systems that are in closed system potential to energy units. There will always be an efficiency or an actual amount of output power you can use divided into the total equivalent power in the form of power expended. So many systems, they require power just to keep the system running that you cannot use, and then whatever you have left is the useful power output. And this ratio between the two is known as the efficiency. So this is the basic general relationship between mechanical, electrical, and thermal power in terms of equivalent power to equivalent power relationships between these three sources of energy, and energy implies the capacity to do physical work. Thanks for watching this lecture and have a great day.